Hi, this is Mrs. Brago, and we're going to do Attack of the Functional Relationships. In this particular section, we're going to talk about evaluating functions, determining domain and range of functions, and it's all linear, quadratic, all different types of functions, okay? And determining what is a function. So let's just jump right in. So this first slide is, I gave you a graph, a mapping diagram, and a table. And in function notation form, remember function notation is f of x, g of x. Remember, it's the function of x. X is still our independent. So in the very first one, it says h of 3. So you're looking at graph, you're looking at the function h, so which would be this very last one, it'll be the table. And you're looking when x is 3. X is 3 right here, so the y value would be 3. So your answer would be 3. How would you write that as an ordered pair? It would be 3, 3. If x is equal to 3, then the value of h of x, which is the function of x, is equal to 3. Let's try another one. So on this one, it has the function notation, the ordered pair, and the verbal statement. So if you notice, it's talking about the function f. So you're looking at the graph this time because you're looking at function f. So the ordered pair says 1. So when x, and we know it's x comma y, so when x is 1. So when x is 1, what is my y value? It's right there at -3. So we can write that in. So how would we write that in as function notation? Well, f of whatever the x value is, and the x value was given to us, it's 1, then our y value will be -3. So if x is equal to 1, our y value would be -3. Let's try one more. On this one, we're talking about the g function. So we're at the mapping diagram on this one. And the verbal, it's given to us this time as a verbal statement. If x is equal to 3, so we're going down and finding the 3. The value of g of x, being the y value, is 0.5. So is that true? Yes, that's true. So how do we write that as an ordered pair? It would be 3, comma, 0.5. And as a function notation, remember it's g is a function of our x value. So the x value is 3. It will equal, because it's g of 3, which means our y value, so it's going to equal 0.5. And here's an extra one for you to do on your own. So let's now go to this one. It says, the statement says f of 3 equals h of 3. Well, let's see if that's a true statement. F of 3, so go to your f of 3, go, your x value is 3, our y value would be 3 as well. So 3 equals, now let's go to the h, our h is over here, h of 3. So 3, look at your x, your y value is 3. So this is a true statement. Remember, you're just finding what the y values are. You're given the x, trying to find the y. This next one, determine the function value for each of the following. F of -3. So go to your, remember that's what the x is. The x is -3. So it's asking what is the y value. So when x is -3, go up and find your y value, which is a +2. F of -1. Go to your x, -1, go up, find your y. It's 3. F of 2. Go to your x value 2, go up and find your y value. And we're going to approximate this as 0.5. Now we're going to talk about discrete versus continuous. Discrete being a scatter plot. They're points on a graph. Your pencil is not drawing a continuous line. Continuous means I start at one point and my pencil doesn't come off the page until I get to the last point. Okay, so for this particular graph is a discrete. It's just points on a graph. And you would label them. You would just go in and label each point. The first one over here would be -5, -1, and so on. Okay, this is a good representation of discrete and continuous. How the first water faucet, it's discrete. A drop, a drop, a drop. It's a drop here and there. Versus the second one is a continuous flow of water. It continually flows. Okay. This one would be obviously a continuous function. So this one's a continuous function because it goes, you take your pencil and you continue to draw through all your points. Your pencil never leaves the paper. The distance traveled by a car versus the amount of time the car has been traveling. Would this be a discrete or continuous? On a normal circumstance, if you think about time would be on the bottom and distance would go up the side of the y-axis, well, can you have it in seconds? Milliseconds? Yes, so it would be a continuous function. So can you determine, that was discrete or continuous. Now we're going to talk about, is it a function? Is it a function? A function you know by if the x's don't repeat. Remember how our inputs, you can only have one input. You can have multiple outputs, but only one input. Remember like a vending machine. Each letter and number represents a type of candy, chip, or some type of snack that's in the vending machine. You can input any number with a letter, and the outputs could be the same thing, but each input is separate. So remember that you can only have one input, but multiple outputs. Okay, so the only thing that we ever look for are our inputs, our x values, and there can only be one of them. So with a graph, we find them to be a little easier because we just draw vertical lines. That was not exactly a straight vertical line. If it only hits our vertical line one time, if the graph only hits it one time, it's a function because that means we only had one x value. But if it hits it multiple times like it did on this one, then it's not a function. So let's go with our vertical lines on this one. So far, only once. Oh, we got to this one, it hits twice, here and here. So we use that x value twice, so this one's not a function. 1, 1, 1, 1, 1, 1. So this one is a function. So looking at the table, can you determine if something's a function? Yes, because you're only looking at your x values, your input. -7, -4, 1, 9. Yes, it is a function. Only looking at our x values. -0.2, 3.4, 2.3, 4.862. All of those are different. It is a function. Go to your x values again. 6, -3, 6. Oh, right here tells us it is not a function. We repeated that input. We repeated that x. So it's not a function. On a mapping diagram, this seems to be the most confusing for students. You have to really look at those arrows. If there are two arrows coming off of our x right here, then it's not a function. 1, 1, 1. So this one's a function. Remember, looking at our x's right here. One arrow. Oh, right here. We used that x value twice. Not a function. Oh, we used the x value 3 times on this one. So not a function. Domain and range. So here's some examples of domain and range. Remember that the domain is the set of all inputs. Domain is the x value, and the range is the y value. Make sure that we do not confuse the two. So we will tackle this domain and range, and then that will be all for this lesson. When we talk about domain, remember, it is all the x values. So what I say is draw a box if you can. And your only domain, you're only going on the x-axis. So it is 0 to 9.5. So 0, and since they were solid circles, it's less than or equal to x, less than or equal to 9.5. Range, we already know that it's the y value, so we're going to go ahead and put that information in. And you only go up the y-axis. So 0 to 22.5. Once again, domain and range of a function. Now, if you notice, there's not a stopping point over here, so I'm going to keep going off my page. And then, oh, I'm going to keep going off my page on that. It never stops. So the domain on this, we can see that we are at -8 right here on the x-axis, but it continues on. So our x value is always greater than or equal to -8 because it continues on. Look at your line right here. It continues on. And then our y value is down here at -10. So our y, as long as it's greater than or equal to -10. So down here at the bottom, and it goes up into infinity. We don't have to write infinity because we can just write it as y is greater than or equal to -10. Once again on this last one, you can draw your box. And you know it's an open circle here, so it's less than. Closed circle here, so it's less than or equal to. Look at the outside of your box. And it hits at -5, less than x, less than or equal to 5. Look at the bottom of your box. It's -5, less than or equal to y, less than at the top of your box. Oh, I apologize, that's 7. I drew my lines in there too close together, and that's 7. So for domain and range, remember that you're looking on the x-axis for domain, the y-axis for range. Don't pick your pencil up on the axis. Don't pick your pencil up. If you're looking for domain, go on the x-axis. And if you're looking for range, go on the y-axis. And it will help you every single time. I hope you have a great day.